We're back, and we're going to be solving an equation with fractions again. So I'm calling this 2, because there'll be a new wrinkle. Again, we can never hear enough that to solve any equation, no matter how complicated, involves undoing what is happening to the variable. One other rule besides this we want to remember is that whatever I do to one side of an equation, I must always do the same thing to the other. So if I subtract 2 from one side, I must subtract 2 from the other side. If I multiply 2 by one side, I'm going to multiply the other side of the equation by 2. Okay, so what is this newer problem going to look like? 2 1/4 plus c equals 2 1/3 plus 1 1/6. So now I have an additional term here. My first step I'm going to want to do is it possible? Are there any like terms that I can combine? So I want to combine like terms, where terms are separated by pluses and minuses. And is there anything that's the same here? Well, it turns out that yes, I have 2 terms here that are both numbers. So let's combine that. But we can see before we combine that, we're going to have to change the denominators because those are not the same. So what can I do? I can certainly make the 3 look like a 6 by multiplying by 2. So I'm going to multiply top and bottom by 2 and rewrite my equation this way. 2 1/4 plus c equals 2 2/6 plus 1 1/6. Now I can combine these 2 terms here. And my equation now looks like 2 1/4 plus c equals 3 3/6. Now I have an equation very similar to what I had in the last video. Now I could, at this point I have some choices. If I want to, I can try to get common denominators. I'm not going to worry about that yet. But my rule here, of undoing what's happening in the variable does come in play. I want to get the c by itself, so I must undo what's happening to it. What's happening to the variable? Well, I'm adding 2 1/4. What will undo adding 2 1/4? Subtracting 2 1/4. And whatever I do to one side of an equation, I must also do to the other side of the equation. So when I do that, these 2 terms here will cancel each other. 2 1/4 minus 2 1/4 is 0. That means the only thing left on the left side is c. On the right side, I have 3 3/6 minus 2 1/4. Let's put top and bottom in with the same denominator, because notice I have different denominators. I must make them the same. So I can do that by multiplying this by 3, top and bottom. And if I multiply this by 2, top and bottom, I will see that I have a common denominator of 12. So 1 times 3 is 3. So on the top I have 3. 6 times 2 is 12. 3 times 2 is 6. So here's my new problem. 3 6/12 minus 2 3/12. Well, that's giving me what? 3 minus 2 is 1. 6/12 minus 3/12 is 3/12. Question, can I simplify this? Can I reduce it? Yes, I can, because both top and bottom are divisible by 3. When I do that, that becomes 1 1/4. So c equals 1 1/4. There's my solution. Let's check it. So 2 1/4 plus 1 1/4. Does that equal, I'm asking the question, does that equal 2 1/3 plus 1 1/6? To shorten our work a little bit, I'm going to take advantage of the fact that I've already simplified the right side right here, and 3 3 to 3 3/6. So 3 3/6 is on the right side. On the left side here, I have conveniently the same denominators. So I'm left with 3 and 2/4. Well, are these the same? Well, yes, these are small enough, and we recognize that 3 and 2/4 is the same thing as 3 1/2. And also, 3/6 is the same thing as 1/2. So, because the two sides are the same, that tells me my solution is correct. And my answer is complete and done. Remember the rules that we used? We always undo what's happening to the variable. And whatever we do to one side, we always do the same thing to the other. You guys have yourself a great day.